Our topic today is a very simple one too: linear and exponential sequences. It is linear and exponential sequences. Exponential sequences. Linear and exponential sequences. If we study this set of numbers, 2, 4, 6, 8, 10, and this 10, 8, 6, 4, 2, and so on, we see that starting from the second number in this set, each number is obtained by adding 2 to the one before it. If I add 2 to the first number, I'll get 4, which is the second. If I add 2 to 4, I'll get 6. If I add 2 to this, I'll get 8, and so on. And in the second set of numbers, I'll say that if I start from the second, each number in the set is obtained by subtracting 2 from the one immediately preceding it. So if I subtract 2 from 10, I'll get 8. 8 minus 2, 6. 6 minus 2, 4. 4 minus 2, 2, and so on. When you notice, when a set of numbers follow this kind of pattern, such an arrangement of numbers is called a linear sequence. So if each term and each number in the set is called a term, each number in the set which represents a sequence is called a term. So whenever you notice that each term of a sequence starting from the second or besides the first is obtained by adding a constant number to the one immediately preceding it, or by subtracting a constant number from the one immediately preceding it, then such a sequence is called a linear sequence. So, and let's look at another. The sets of numbers above. The sets of numbers above represents linear sequences. And you can also call it an arithmetic progression. Now let's take another example. Consider this other example. These other sets of numbers: 2, 4, 8, 16, 32, and so on. And this 64, 32, 16, 8, 4, 2, and so on. We'll say that in this set, starting from the second number, we have to multiply the number before it by 2 to get it. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 6, and 6 times 2, 32, and so on. And here we are dividing, starting from the second, we are dividing the number before it by a particular number to get what should be here, to get this number. So 64 divided by 2, 32, 32 divided by 2, 16, 16 divided by 2, 8, 8 divided by 2, 4, and so on. So you see that if you start from the second, the number before the number we are talking about is divided by a particular number to get the number we want. So to get this, which is 32, I'll divide the one before it, which is 64, by 2. And to get this, I'll divide 32 by 2, and so on. So whenever you notice that the numbers in a set of numbers besides the first, each number in a set of numbers besides the first is obtained by multiplying or dividing the number immediately preceding it by a constant number, then such an arrangement is called an exponential sequence or a geometrical progression. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 64 divided by 2, 32, 32 divided by 2, 16, 16 divided by 2, 8, 8 divided by 2, 4, 4 divided by 2, 2. So we can see that each term of this sequence besides the first is obtained by multiplying the term immediately preceding it by a constant number, and that constant number is 2. And here each term besides the first because the first doesn't have a preceding term, that's why we say each term besides the first is obtained by dividing the term immediately preceding it by a constant number. In this case, that constant number is 2. So these are also examples of an exponential sequence. So 248 up to 32, 64, and like that are also examples. Oh, yeah. The set above are also examples of an exponential sequence. Which you can also call a geometric progression. So we learn the mean. Okay, yeah, the nth term of an AP, which means an arithmetic progression. The nth term Tn of an AP is given by a plus n minus 1d, where a is the first term of a sequence or progression, and d is the common difference. The difference between the term and the one immediately preceding it is called a common difference. D represents a common difference and A is the first term. So if you want to find any term of a linear sequence or an arithmetic progression, this is the formula you use. Tn equals a plus n minus 1d. Now we go to arithmetic mean. Arithmetic mean. What is the arithmetic mean? If P, Q, and R are consecutive terms, of an AP, then Q is equal to the common difference D, then D, which is the common difference, is Q minus P, and D is also the same as R minus Q, because we have said the common difference is the difference between the term and the one immediately preceding it. So if P, Q, and R are consecutive terms of an AP, that means the common difference D is Q minus P, and it's also R minus Q. So that simply means Q minus P is equal to R minus Q, and this means 2Q equals P plus R, and therefore Q equals P plus R over 2, and where Q is called the arithmetic mean of P and R. So the term in the middle of any two terms of an arithmetic progression is called their arithmetic mean, and it's given by this definition: Q equals P plus R over 2 if P, Q, and R are consecutive terms of an AP. Now let's take a very simple example. In set in set 3 arithmetic means between 19 and 32. this question requires that we put three arithmetic means, three arithmetic means between 19 and 32. That means we have to put three other terms in the middle of 19 and 32 such that all of the terms are in arithmetic progression. That's quite easy. Let P, Q, and R be the arithmetic means. That means P, Q, and R be the arithmetic means. P, Q, and R are the terms in the middle of 19 and 32. So if P, Q, and R are the arithmetic means, we know that T1 is 9. Okay, if P, Q, and R are the arithmetic means, that means 19, P, Q, R, and 32 are in arithmetic progression. If P, Q, and R are the arithmetic means between 19 and 32, that means 19, P, Q, R, and 32 are in arithmetic progression. And that means T1, the first one, which is A, the first term, which is A, is 19. I want to write that. T1, which is A, is 19. And T1, 2, 3, 4, 5, T5, which is given by A plus 4D. Going by the definition, Tn equals A plus n minus 1D, is 32. So that means A plus 4D equals 32. A plus 4D equals 32. And that means 19, because we already know A to be 19. 19 plus 4D is equal to 32. Plus 4D equals 32, and that means 4D equals 32 minus 19. So 4D equals 32 minus 19 is 29. 32 minus 19 is 12, and therefore D is equal to 3. So since we know D, we can easily find the remaining terms. P is the second term of a sequence and is given by A plus 4D, and that's going to be 19. T is the second term and is given by A plus D, so that's 19 plus D, which is 3, and that means 22. Q is the third term of the AP, and that's given by A plus 2D, which means 19 plus 2 times 3, because D is 3. And that's 19 plus 6, which is 25. And R is the fourth term of a sequence, which is given by A plus 3D. And that's equal to 19 plus 3 times 3, which is 19 plus 9, and that's 28. 9 plus 9 is 28. Therefore, the arithmetic means are between 19 and 32 are the arithmetic means between 19 and 32 are 22, 25, and 28. So those are the numbers in the middle of 19 and 32, and they are called their arithmetic means. So that's it simply.